nonlinear models and methods. So the target of this tutorial would be about learning about nonlinear methods and models, learning about about curve fitting in mathematics, and also how to use the curve fitting tool provided by MATLAB. So now nonlinear least squares. Now curve fitting toolbox software uses the nonlinear least squares formulation to fit a nonlinear model to data. A nonlinear model is defined as an equation that is nonlinear in the coefficients, or a combination of nonlinear and linear in the coefficients. Now, for example, Gaussian ratios of polynomials and power functions are all nonlinear. Okay, so now we come to tool fitting. I mean, this is how the interactive tool curve fitting tool. This is the process that is followed in MATLAB. First of all, we open the surface or the curve fitting toolbox. We select the data, we refine our fit, we remove outliers, we select the validation data, and then we start exploring and customizing the plots. So now let us start with an example. Okay, so let us start with using the curve fitting tool. The command for that is the CF tool in MATLAB. So here we go. Here we have the curve fitting tool. Okay, so it's visible now. Yeah, so here we have the curve fitting tool to our disposal. So the first step would be selecting a proper data. Now let us use a predetermined data in MATLAB, that is a census. So first of all, we'll have to load census. So here we have the C date and the population, the year date and the population. Okay, so this is a dummy data which can be used for examples. Okay, so now let us load this data first of all. So X data, let me have C date. Y data, let me have population. Okay, so this is the curve it is showing me if I have C date and population. Right. Okay, so the date set map is population versus C date. So I create this data set. So I have a data set that is POP versus C date. Now I'll use this to fit further my curves. Okay, so this is done. It is showing here I have the pop versus C date curve over here. Starting from the 1800s to the 1980s, I have the population here. Okay, so now we carry on with the fitting. So let us fit a curve onto this. Yeah. Okay, so we'll go with a new fit. Okay, let's start with a linear polynomial, and here the data set is population versus C date, which we had just created, and so here I copied my linear fit here. So it'll be straight line, of course, because it's a linear fit. So now let us try some more fits. Let us try the quadratic polynomial fit. Okay, so apply this. Here you see this is my quadratic polynomial fit. It is almost as good as my actual data point, but not completely. Let me try the cubic polynomial fit. So here I have here goes the cubic polynomial fit. Now if I try the 4-degree polynomial fit, right, so they're overlapping again and again over my data. So this is the different curves that I've used. Okay, let me try a 9-degree polynomial fit. So you can see it's overlapping again and again in a better and better manner with my data points. Okay, so this is about fitting the curves with the set of data points. Okay, now let me remove the unnecessary fits. Let us choose one fit to work upon. uh, yep, okay, so fitting, let us keep just one. Let's say we'll have one poly 3. Rest all, let's remove them. Delete fit, delete fit, delete fit, delete fit, and delete fit. Okay, so we'll have one fitting here. As you can see, this is one fit. Now let us see the residuals. Go to view residuals, line plot. So it is calculating the residuals. Yeah, so here we can see the residual of the fit. Here we can switch on the grid over here, have this grid to have a better view of the points. We can pan, we can zoom in, then we can pan with the hand tool like this. Okay, yep. Okay, now let us analyze this fit. We can use the first derivative at xi, or we can use the second derivative, both. Okay, so let's use just the first derivative at xi. So here it is, this is the analysis of the fit with respect to the first derivative of xi. If we apply this, yep. So this is analysis. We have the d of fxi with respect to dx. We have the derivative, the first derivative at several points. Suppose we wanted, we can also plot these results on the curve. Okay, so here we have the derivative. Let us see the second derivative. Okay, so here we have the curve for the second derivative. This is the second derivative plot. Right here, and this is the original curve fitting plot along with the residuals. So this is how we use the curve fitting tool in MATLAB.